I'm Noah Armbruster. I'm presenting for Group 20, and in this presentation, I'll be showing you how we applied the engineering design cycle in the construction of our FEDD project, which was a music maker. So the first step of the engineering design cycle is to ask, and we had some project constraints that were given to us by our rubric. Some of the constraints were to play at least 10 seconds of a recognizable song, to be mechanical in nature, and to be less than 3 feet in each dimension. On the right, you can see a picture of a music box, which is a type of music maker that we ended up drawing a lot of inspiration from. The next step in the engineering design cycle is to imagine. So for each group member, we all drew a prototype of what we thought we could do for our project and what we thought would be a good idea for a music maker. And then we went through all our prototypes as a group. They all had different ways to play music, and we all came at it from a different angle. Next was to plan. So we selected the solution that we thought would work best and we'd be able to best implement, and then designed it in CAD. It was similar to a music box, as you can see in the image on the right, and we plan to utilize 3D printing and use a kalimba, which is a finger piano, as our instrument. The next step is to create, and we created our first prototype of our design. We had to modify our kalimba to work with our design since the keys wouldn't have lined up with the drum, and you can see in the image on the right how we had to reposition the keys on the instrument. Next, we had to test our design. We'd moved on from our original prototype and printed another that included a drum with some pins built onto the wheel to help test its function. It didn't have a song programmed yet. We evaluated our design, seeing what we'd have to change and what we would need to improve in our next iteration. And in the photo on the right, you can see what our first prototype looked like up against the kalimba. The last step in the design process is to improve. In our improved prototype, we fixed many of the issues that we found in our first prototype. Our new prototype also included the final song that we wanted to play, which was Mary Had a Little Lamb. In the photo on the right, you can see the final version of our prototype at FEDD. Even though it didn't end up working perfectly, failure is a huge part of the design process. And I think if we had more time, we could have used the mistakes that we found in our most recent prototype and improved on it to make it function even better. Now that we've gone over the design cycle and how we applied it in our project, we can move on to some videos that we took at FEDD where we showcase our final project and the materials that we had supported.
We're today here at FEDD. Here's our music maker. So pretty much here's a few of our CAD designs throughout the process. We had about 6 iterations. We initially had it a little bit more complicated and then decided to simplify it down. From here we have like a little too many mechanical parts. We had things go wrong, so we decided to simplify it to essentially the crank, the gear to crank the drum, and the drum holder itself on top of the kalimba. We decided to have it play Mary Had a Little Lamb, so you have like the sheet music here, what it looks like. Just like some cool little pictures. On top of that, why you should buy our product. It's easy to use, compact, sturdy. We tried to break it and it didn't even break, so it's definitely sturdy. It's compostable and fits many small kalimbas, so you can use it for different kinds of kalimbas.
I'm Dorian Lineberger. This is our FEDD project, a mechanical music maker. It's supposed to function as a music box with a kalimba and a wheel that spins and hits the notes. Our wheel isn't quite big enough to fit and hit the notes, so it doesn't really play the song as it's supposed to.
Maybe we do testing and then talk.
Noah, I'm just going to do a little demonstration also of how it's supposed to work. So these gears here are supposed to mesh with our crank and turn the wheel. We've been having a little trouble with getting it to work though, but as you can see, it's meant to turn the drum. Oh, there we go, a little bit, yeah. Which then hits the keys on the kalimba, which we had to rearrange to get it to hit all of them because it was formerly in a V shape. You can retune it. There's so much stuff you can do with this. You can change out the drum to get a new song. You can put it on a different kalimba. There's so much you can do. The possibilities are endless.
Hi there, I'm Rohan Gowda, and I'm here for the music maker for Group 20. And I'll be talking about the 3D printing process and what we had in mind. So the first thing that we had in mind when we were designing this was to have it modular. And what we mean by that is have it be able to play multiple different songs and have it be able to be coded in different ways. So what we basically did when we were designing this was try to attempt different methods. We went over, I think, maybe 5 different bass designs before ending up with something that we thought was the best to go with. We went from using piano tiles to guitar strings, but eventually ended up with a kalimba as our bass model. And using the kalimba, we started to design our CAD drawing using a drum with different pegs as seen here. And each drum is operated by a crankshaft, which is accessible, which was something we found very important. And one of the biggest parts of our project, as I mentioned, was it being modular. We can disassemble every single piece of this and package it, and each piece can be replaced individually in case something goes wrong with the model.